Assalamu alaikum. This is a very simple exercise about group. We consider G the set of the interval open interval minus 1, 1, x star y, the composition law is defined by x plus y divided by 1 plus x y. Show that this is a group. This is well defined, so is an operation well defined. What we mean by this? We mean that the result, this, should belongs to G. Otherwise, it cannot be a good operation, composition law. How we can do it? X plus y over 1 plus xy. This is less than 1 and greater than minus 1. Why? Because if we take this side, this is equivalent to x plus y less than 1 plus xy. This side. And this one is equal to xy minus x minus y minus x minus y plus 1. Is it greater than 0? This is equal to x minus 1 times y minus 1 greater than 0. Is it true? X minus 1 times y minus 1, xy minus x minus 1 plus 1. This is negative. This is negative. So this is positive. From this side, it's okay. From this side now. From this side. We have, this is positive because x and y are in minus 1, 1. This is positive because x and y are in minus 1, 1. Minus 1 minus xy less than x plus y. Is it true? We take this from this side. This is equivalent to xy plus x plus y plus 1 greater than 0. But this one is x plus 1 times y plus 1, and this is greater than 0. Why? Because x plus 1 is greater than 0 and y plus 1 is greater than 0, and if we time two real number which are greater than 0, it is greater than 0. So this is well defined. The result belongs to minus 1, 1. How about the structure of group? I prefer remark that the operation, the composition is commutative. Obvious. X plus y is equal to y plus x, and xy is equal to yx. So it is obvious. Since it is commutative, we will carry on proving that it is the natural element, the opposite element, just doing just one hand and not the two conditions. Do we have an natural element? Suppose that the natural element for this operation is denoted by E. This E is supposed to verify two conditions. For all x in G, x composition with E equal to E composition with x and equal to x. But since we remarked that this operation is a commutative one, we are not supposed to verify this one. We verify just one, it is sufficient. Let us start from this one. X star A is equal to x plus A over 1 plus xa. This is supposed to be equal to x. Abracadabra, x plus e equal to x plus x squared e. We cancel this with this. From here we have e equal to x squared e. And from here we have e times 1 minus x squared equal to 0. 1 minus x squared different of 0, so e is equal to 0 because we are in a separable space. A equal to 0. This is the natural element. For this composition law, there exists a natural element which is equal to 0. This is first. Second, about the opposite. For all x in G, for all x belongs to does there exist x prime also from G such that what? Such that x star x prime equal to x prime star x equal to e. But since we proved that we remarked that it is commutative, we can just deal with just one equation. X plus x prime equal to 0. This means that x plus x prime over 1 plus x prime equal to 0. This implies that x prime is equal to minus x. So we proved that there exists an inverse element for each element of G, and actually this one belongs to minus 1, 1, so it is in G. The third and the last condition about associativity. Let x, y, and z belong to G. Do we have x star y star z equal to x star y star z? Actually, it is a simple verification. Here we have x star, the element is y plus z over 1 plus yz, which is equal to x plus, this is the new element, y plus z over 1 plus yz over 1 plus x, the new element, y plus z over 1 plus yz. This is from the first side. For the second side, we will get x plus x y z plus y plus z over 1 plus yz, and here we will get 1 plus yz plus 1 plus yz plus xy plus xz from this side. The second side, this one, this is equal to x plus y over 1 plus xy star z. This is the new element on the second side. This is the new element. So this element, x plus y over 1 plus xy star z, this is equal to sorry, this is equal to x plus y over 1 plus xy plus z over 1 plus z times x plus y over 1 plus xy, and this is equal to x plus y plus z plus xyz, and here this is equal to 1 plus xy plus zx z plus zy. We cancel 1 plus xy with 1 plus xy, and it will be equal. So this is a group, actually this is a commutative group. I finished. Thank you very much. See you next time.